Today we're talking about section 1.3, rate of change and initial value. While this may seem somewhat like a review and be somewhat of a review, is very, very important section. This is something that we're going to be using the rest of the year. So let's talk about rate of change and initial value. Let's go to work. Let's start by rate of change. The first thing that should come to your mind, or often comes to mind when we think of rate of change, is slope. What is slope? Rise over run. What is slope? Rise over run. It is also known as the change in y over the change in x. Now I said change and I wrote a little triangle. Those you may not know, the triangle is a Greek symbol called delta, and it means change. How did your book define rate of change?
The measure of how something quickly changes.
The measure of how quickly something changes. There's another line in there that says, I believe, especially when you're talking about linear functions, which we'll have a whole chapter on or a whole unit coming on, sometimes they'll call it the steepness of a line. Okay, the steepness of a line. Now, rate of change can be found a couple ways. Okay. It can be found by counting it, which is the easiest way, counting the rise and the run. So that's the first way. And the second way is by using the slope formula. What is the slope formula then, you may ask? Well, it's y2 minus y1 over x2 minus x1. By a show of hands, how many of you remember seeing that and working with that in the past? Okay. I'm going to state a fact here. Those of you who didn't raise your hand have worked with this in the past. Like, I know you have, without a doubt. Okay, so it's my job to get that back into your memory somehow. Okay, we're going to use that slope formula. We're going to use it a lot. And I want you to get really good at it too, to be able to do it very quickly and painlessly. I'm going to start by talking about counting slope. Okay, and I'm going to come in here to this nice little graph I have. And let's say I have this point, which would be what, -2, -1. And let's say I have this point, which is 3, 4. Let's say I have a line going through those 2 points. How's that? Pretty good? Now, I can find the slope of that line a couple different ways. The first and easiest way to find it is to count it. And I'm just going to count the rise. Oops. I need to get back to my pen. The rise and put that over the run. For me, I always start at the left and count my run first. It's just me. You can go any direction you want. But I start at the leftmost point and go 1, 2, 3, 4, 5. Oops, that's it, 5, right? 1, 2, 3, 4, 5. Now I'm directly under, and that was my run. And now I got to go up 1, 2, 3, 4, 5. So I had to go up 5. So 5 over 5 is 1. So that particular line had a slope or rate of change of 1. The other way I could find the same slope is to use the slope formula and think, hey, this is x1 and y1, and this is x2 and y2. Now, it doesn't matter which way you label them. I could have switched those labels. It's just one of them. They have an x and a y, and they're both 1s or they're both 2s. That's all that matters. Does that make sense? Now I plug it into the formula. What formula? y2 minus y1 over x2 minus x1. So if I plug it in, 4 minus. Now notice that minus is that minus right there. What do I need to minus? y1, which is a negative 1. Notice there's 2 negatives there, right? I'll fix that in a minute. And then x2 is 3 minus x1. x1 is a negative 2. What happens when you minus a negative? Actually add it, right? So this slope ends up being 5 over 5, which is 1, which we already said. Yes? Notice how I get the same thing no matter which way I do it. There's 2 ways to find slope. To count it or to use the slope formula. Cool? All right. It seems cool, but you're going to be doing that over and over and over in this section. All right. I'll come back to it. Okay, so are we okay with rate of change? I like to call it rate of change more than slope. Slope is the steepness of the line, and come on, let's be honest. We live in Ohio. You guys understand the difference between sliding down or sled riding down this hill and sled riding down that hill. Huh? One of them's fun, one of them's not. Yeah. We understand the steepness of a line. That makes sense to us because we go sled riding.
There's like a big hill in Missouri.
There's a big hill called Stalker Hill, too. The other thing that was shown to us or that we learned about in this section or read about is the initial value. Okay? Initial value is also known as, let me get back to my black here, as a constant. Remember I shared that with you the other day, and constant's just a number by itself, doesn't have a variable with it, right? Initial value, constant. It's also the y-intercept. Your book defines it as the value of the function when the input is 0. The value of the input, the value of the function when the input is 0. Now, here's something really cool. When we're given a function in equation form, say I give you f of x equals 2x plus 3. You should be able to see your initial value very quickly and easily. It is the constant, it is the y-intercept, it is the initial value. It's at the end. The definition said the value of the function when the input's 0. But watch what happens anytime I have an input of 0. So I find f of 0. That ends up being 2 times 0 plus 3, which is 3, right? Even if I gave you some crazy function like this, f of x equals x cubed plus 2x squared minus 4. I'm telling you, you should be able to look at it and see the initial value is negative 4, right? But even if we input, like the definition said, input is 0, we'd have 0, cubed plus 2 times 0 squared minus 4, which ends up being 0 plus 0 minus 4, which is negative 4. See how it's always the same thing? And that's a really cool thing to also know that that constant or that initial value is also the y-intercept. So it's just as easy, even if I give you a crazy graph like that, to know what's the initial value. Well, I don't have it numbered right now, but it's right there, yeah? It is your y-intercept. In this case, it looks like it's 1, yeah? So initial value should be very, very easy for us to find. What if it was on a table? Can anybody tell me my initial value? 6. How did you know that? Because it's when the input is 0, the value of the function when the input is 0. So see how easy initial value is. Yes? All right. Do you think you're okay with finding the rate of change and the initial value? Okay, I'm going to do a couple problems with you, and I'm going to show you in your homework that it's not necessarily hard. It's just going to be a lot of work. Okay, so if you would, turn with me to problem number 1. I know that's not your homework for tonight, but I want to show you problem number 1 on your homework. Now, I'm going to do this work right here, but I'm going to go ahead and tell you right now, you're going to need another piece of paper. I'm going to fill up this whole section with my work. I'm just telling you right now. So please get out a blank sheet of paper. See, because the directions tell me to calculate the approximate rate of change for the following functions of over the interval -4 to 4, and then again from -2 to 2, and then finally give the initial value. So it's asking me to find the rate of change twice and give the initial value. Now, on my example, right here, I used a straight line. That was easy to find the rate of change. And the other thing about something that's linear, the rate of change is always constant, or it's always the same. Okay, but that's not always true. Like, if I'm calling a little timeout here, and I have, say, this graph. Does that graph have a constant rate of change? No, it doesn't. It has different rates of change. Matter of fact, if I looked at the rate of change from, I don't know, here to there, it might be one thing. And then the rate of change from here to here might be slightly different, yes? So what we do in those cases is we basically just find the rate of change from those points and call that the average rate of change. Are you with me? Okay. Now, if it's on a graph, that's somewhat easy to do. I'm going to give you one more example. What if I had this function, and I wanted to find the average rate of change from, we'll say -4 is here to 4. So right there is -4, and there's 4. That's one average rate of change, yeah? And then what if I wanted to find it from, also, from -2 to 2? Well, here's -2, and there's 2. I would find that rate of change as well. Are you with me? Now, there's only 2 ways to find rate of change. One is to count the graph, and the other is to use the slope formula. And that's what I have to do on these problems. So, basically, I have to input -4. All right, stay with me. Here we go. So I got to put in -4 into the function. So -4 minus 2, quantity squared, minus 7. Everybody okay with the fact that I've plugged in -4? I'm doing that because it tells me right here in this direction. Oops, go away. Right here. All right. Now I simplify. -4 minus 2 is a -6. -6 squared is 36. 36 minus 7 is 29. Now I did all that work just to find that my input is -4 and my output is 29. Cool? Now I'm going to do it again for 4. Find f of 4. Okay. 4 minus 2, quantity squared, minus 7. Well, 4 minus 2 is 2. 2 squared is 4. 4 minus 7 is -3. So I did all of that work just to find out that my ordered pair, my input is 4 and my output is -3. Yes? Now I have to find the rate of change between those 2 points. How do I find the rate of change? Use the slope formula. I'm going to go x1, y1, x2, y2. So that would be 29 minus a -3 over -4 minus 4. Minus a negative becomes plus. That's 32 over -8. 32 divided by 8 or -8 is a -4. So my rate of change from -4 to 4 is -4. I did all of that work for this one thing. I got to do it all again for this one, for -2 and 2. Ready? So f of -2 is -2 minus 2 squared minus 7. -2 minus 2 is -4 squared minus 7. -4 is 6 squared is 16. 16 minus 7 is 9. So I did all that to find my input's -2, my output's 9. Cool? Now let's find f of 2, which is 2 minus 2 squared minus 7. Well, 2 minus 2 is 0. 0 squared is 0. 0 minus 7 is where? That good?
Yeah.
All right. So I did all of that to find out my input's 2 and my output's -7. x1, y1, x2, y2. So I got -7 minus 9 over 2 minus a -2, which is a -16 over 4, which is a -4. So my rate of change from -2 to 2 was also -4. And I will tell you, it does not always come out to be the same. Sometimes it does, but not always. And the last thing I need to find is finally give the initial value. What's my initial value? -7. Initial value equals -7. Now, I'm supposed to plug in the 0, right? But do I have to? Not really, not in this case. And I did all of that work just for problem number 1. Yes. We good? I'm almost done. I'm going to do one more for you. And because I just want to see the difference between when we deal with points, when we deal with a graph. Okay. All right. Jump down to number 7. The directions are still the same. I have to find my rate of change from -4 to 4. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So my rate of change from -4 to 4 is, it's over 8, and then rise 1, 2, or 1/4, right? I did not. It's in the directions. -4 and 4, right? And then I got to do it again for what? From -2 to 2. Well, my x values are -2 to 2. Well, -2, my point's down here, and 2, my point's right there. Yep. Okay with that? So my rate of change from -2 to 2 is 1, 2, 3, 4. And I go up approximately 1. Now, neither one of those points are on the line, are they? Or on a lattice point. But I can estimate where they are, and that's okay. And basically from there to there to there to there, that's about 1 point up, right? Are you with me? And I'm okay with that estimation for now. So my rate of change is 1/4. And the last thing is my initial value. What's my initial value? It's right there. It's about -2.7, right? Anywhere close, and I'm good with it. See how that's done?
Fractions are much easier.
Fractions are easy. Fractions rock. It was a -2.7 because I'm below 0, right? Now, I do want to tell you, like 13, I got to find my slope from -4 to 4. So there's my 2 ordered pairs. I got to find my slope from -2 to 2, and I got to find my initial value. That's what you're doing this entire homework. Okay? Only doing the evens, 2 through 22. That's 11 problems. Okay? Good luck.